Let us consider the solution of this problem. Suppose that 6 cards are taken from the standard deck of cards without replacement, meaning we take the card and we don't put this back. What is the probability of taking 2 cards, which are red, and 4 black cards? We're going to solve this problem in 3 different ways. The first problem is using the probabilities. I would like to find the probability of taking the 2 red cards first and then 4 black cards without replacement. The probability of such a combination is the probability of choosing the red card on the first row. So there are 26 red cards in total, and I need to choose one of them out of 52. Then I need to choose now again the red card. So there are 25 red cards left and 51 cards left in total. Then on the third row, we need to take the black card. There are 26 black cards left and 50 cards left in the deck. Next row is again the black one, 25 over 49. Then again the black one, 24 over 48. Then again the black one, 23 over 47. So basically we can write this down as the permutation of the 6 out of 52 multiplied to the 26 in the square, multiplied to the 25 in the square, multiplied to the 24 and 23. Now what we need to do is we can draw this 2 red cards and 4 black cards and how many different permutations. So how many different permutations there exist for such a cards, for such a combination of the cards. So what we need to do is we need to find the so-called the outer permutation. We consider that the red cards and their permutations are considered as the same. So that is why the outer permutation, or the permutation is when we mix them, is the 6 factorials over 2 factorials multiplied to the 4 factorials. And there are such a number of the permutations of the 2 red cards and 4 black cards, and choosing the 2 red cards and the 4 black cards are always the same, so we have to multiply this to the 26 in the square, 25 in the square, multiply to the 24, multiply to the 23, and divide this to the permutation of 52 and 6. So next we can try to solve this problem differently, saying let's assume I would like to choose the 6 cards. So where the order is important. So in the first place I can choose 52 cards. In the second place I can choose 51, then 50, then 49, then 48, then 47. So if I choose 6 cards without replacement, there are such a case of taking different cards in different order. So basically this is the permutation of the 52 and 6. So this will be my sample space. So next what I need to do is I need to figure out the number of the ways where I can choose the 6 cards, where the 2 will be the red and 4 will be the black, and when the order is important. So I can choose the number of the ways of choosing 2 red cards out of 26 is the combination of the 2 and 26. And the number of the ways to choosing 4 red cards, 4 black cards out of 26 is the combination of the 4 and 26. So the number of the ways of choosing the 2 red cards and 4 black cards is their multiplication. Now once we chosen them, we need to multiply this to the 6 factorials since the order is important. So the probability of choosing the 2 red and 4 black is the combination of the 26 and 2 the combination of the 26 and 4 multiplied to the 6 factorials divided to the permutation of the 52 and 6. Please note that this answer is the same as the solution, the answer of the previous solution, since we can write down these combinations as 26 factorials over 24 factorials multiplied to the 2 factorials multiplied to the 26 factorials divided to the 22 factorials multiplied to the 4 factorials multiplied to the 6 factorials, or permutation, or we can divide the 26 factorials to the 24 factorials and we can get 26 multiplied to the 25, and we can divide the 26 factorials to the 22 factorials and get 26 multiplied to the 25 multiplied to the 24 and 23 divided to the permutation of the 52 and 6 multiplied to the 6 factorials over 2 factorials and 4 factorials. So at the same time, we can try to solve this problem differently. So let's assume I would like to choose 6 cards out of 52, where the order is not important. So basically, the number of the ways of choosing 6 different cards out of 52 is the combination of 52 and 6. So this will be now the sample space. So choosing the 2 red cards, any 2 red cards out of 26 is the combination of the 2 and 26. And we have to multiply this. There's a combination of the 4 and 26, which is the number of the ways of choosing 4 black cards out of 26. So we have to divide this to say choosing 6 different cards out of 52. Please note that this is the same answer as the previous ones because we can write this down as. So 26 multiplied to the divided to the 24 factorials divided to the 2 factorials multiplied to the 26 factorials over 22 factorials multiplied to the 4 factorials. Here we've got 52 factorials over 46 factorials multiplied to the 6 factorials. So by just dividing the factorials, so this 26 to the 24, 26 to the 22, and 52 to the 48, we can get the answer. 26 multiplied to the 25, multiplied to the 26, multiplied to the 25, 24, and 23, over 52 multiplied to the 51, 50, 49, 48, and 47, multiplied, so the 6 factorials go up, 6 factorials divided to this 2 factorials and 4 factorials, which will be 2 factorials multiplied to the 4 factorials. Basically, in all 3 different ways of the solutions, we've got the same answer.